So welcome everyone to another edition in this series of our Why SOLIDWORKS series. This one's design validation and cost savings. I'm Jared Spaniel, an applications engineer out of our Fresno, California office. So let's jump into this and see what we're going to be talking about today. Brief overview of the webinar. Now when we say design validation and cost savings, you might be thinking simulation, but I'm taking it a little bit of a different direction today because I really want to cover some tools that I don't think get touched on very often, and that is the Evaluate tab tools. So the format is basically I'm going to tell you what the tools do, and then I'm going to tell you what they're good for. And I'm going to show you a little bit about how you can use them and some of the benefits of using these tools. So my goal here is to help you guys discover some of the lesser known evaluation tools included within SOLIDWORKS. So where to start? How are you going to access these tools, right? You have to enable the tab first. Very simply, just like you enable any other tabs within SOLIDWORKS, like your mold tools, sheet metal, weldments, any of these types of things. It's a right mouse button click on the tabs, and then you're just going to check evaluate, and that's going to open up that command manager toolbar. So this tab contains all the tools that you're going to need to evaluate your model. There's, on a high level, a few different ways that are classified to evaluate the model. These are like things like dimensional, the performance of the model, the mass properties, and then of course you have your simulation tools like Simulation Express, Flow Express, those types of things. So this is basically how I've broken it down. I'm going to show you how to access this in SOLIDWORKS in a moment here. But basically this tab, the Evaluate tab, has about 3 different categories. There's a beginners category, there's intermediate, and then there's the advanced category essentially. So the beginner stuff is things that are pretty common that probably everyone uses. Those are tools like your measure tool, mass properties. Maybe a few of these are a little bit less used like section properties, the sensor tool. Performance evaluation probably should be used more than it actually is. Then you have your intermediate tools. These are things that you use to check your geometry, like check, geometry analysis, zebra stripes, curvature, mold tool specific things like draft analysis, undercut analysis, thickness analysis. Then there's the advanced section. And these are things that kind of get your feet wet for simulation. So that's your Simulation Express, Flow Express, DriveWorks Express. Then we have costing and sustainability, right? So how do you access this tab? Let's jump over to SOLIDWORKS to take a quick look. Very simply, right click on the tabs here, and you'll get a list of all the tabs that are accessible to you. So here we have the Evaluate tab. A check mark next to that indicates that it's showing, it's accessible. And if you didn't know, there's a bunch of other tabs in here like mold tools, sheet metal, surfaces. So if you ever can't find any of these, just right click on any of these tabs and it'll get you access to whatever's available to you. You can see in this case I have MBD, other tools like mold tools, the sketch ink, which is new, and then of course the ones that everyone uses every day, features, sketch, those types of things, right? So there's quite a few tools that I want to hit on today, so we may run a little long, but I want to make sure that I kind of gave you the broad strokes and the brief overview of everything here that's accessible within this tab. So the tools here, there's about 16 different tools on this tab that I'm going to talk about today. Basically, here's the list of those tools, right? We're going to talk about all these tools in varying depths. So there's a great wide variety of things here. I'm not going to get into the mold tools very specifically, and I'm not going to get into the simulation or the express tools very in depth at all either, because those are just a little bit more advanced and they're kind of out of the scope of this webinar. So the first one, probably the most commonly used tool on this tab is the measure tool. I use this all the time. I've seen everyone use it all the time. It's very handy. It's very easy to use. And simply put, what it does, it measures things, right? It's it's basically a tape measure for SOLIDWORKS or a ruler. And it's capable of measuring the length of an edge, area of a perimeter surface, distance between two surfaces, edges, corners, or a radius or diameter of an edge, right? So let's take a look at this tool in action. Very simply put, I'm going to look at an example here. Let's take a look at this guy. If we want to measure something, all we have to do is open up the measure tool, couple options up top here to notice. The units, so if depending on what units you want to measure in, you can change those things in here. You can use the document settings, or you can use your own custom settings to specify it, right? We can do a point-to-point, and we can even look at our measurement history. Here's the types of measurements we can do. We can do min distance, max distance, center to center, or a custom distance, right? So in this case, I'm just going to do an example of like this face to this face, and what we get is a bunch of feedback here, and you can move these around to make it a little bit more clear for you. The one that most people are usually concerned with is just the normal distance, which in this case is my 40 millimeters. But conveniently, it also gives you the area and the perimeter, and a couple other dimensions like your delta X, Y, Z, right? One thing that's cool that they just introduced this year that I really liked about this tool was they added the ability to resize your fonts in here. So it used to be really small like this. Now you can increase the font up to 3 times that size. So it goes to this size here is the biggest you can go. But a very convenient tool. Say if we want to measure the diameter of this cylinder here, of this threads, 33 millimeters, also gives us the area and the perimeter, right? So just a simple click. If you want to clear this out, right click in the blue selection manager, clear selections, and you can start again. So if you want to measure here to here, we can do that as well, right? So it gives us our normal distance, 28.36 right here. Gives us a diameter of 22 millimeters and the other feedback as well. That's all it is. Very simple, very useful tool. If you're showing a presentation or something, or if you get a model and you want to check some dimensions, this is the tool to do it with, right? Let's take a look at the next one, mass properties. So another pretty common one. If you've taken any of the SOLIDWORKS certifications, or if you're going to take any of the SOLIDWORKS certifications, you're going to need to know about this tool, because what they're going to ask you is the mass. So you're going to make some changes. You may do a few things, and they'll probably, in a varying cases, will ask you the mass of your model. So that's going to be the answer. That's going to tell them whether you've modeled it correctly or not. So what it does, it gives mass properties, right? There's a variety of valuable info in one dialog box that you can see here on the right. The key here is don't forget to specify your material. Main thing is the material properties are needed to give a correct mass for that material. Quick tip is the single colored triad indicates the center of mass of the model. And the parameters that we can get from this are mass, volume, surface area, center of mass, our principal axes of inertia, moments of inertia. So let's take a look at this one real quick. Mass properties, number 2. Hit the box. It opens up the dialog. We can see the key one here we want is our mass, but it also gives us our volume, our surface area, our center of mass, all those types of things, right? So if we look at that again, our center of mass is right here, and it's showing that just as I said, right? Single colored triad indicates the center of mass. So if that's important to you and you're trying to adjust for the center of mass, it's good to know where that is. The other one here is I'm pulling this mass from this material property, so I have a 4340 steel specified, so the mass properties are coming from that. Now if you want to look at this in a different units, you can totally do that. Maybe we don't want to look at this in grams. We can jump up here. We can say use custom settings. We want to look at this in pounds. 1.87 pounds is the answer, right? So a couple other things that you can do in here, but that's really the main keys of it. So let's take a look at the next one. Section properties. So this one's cool. Basically what it does, it evaluates section properties for multiple faces that lie in parallel planes. What it's good for is mainly getting the area of a face quickly. The tip here is when you evaluate more than one entity, the first selected face defines the plane for the property calculation. Got another quick, easy example right here. If we want to do our section properties, it looks very similar to the mass properties box. What we're going to do is select a face, hit calculate. It gives us the area, right? One thing you might be saying to yourself is, well, I can get that from the mass properties, right? So it gives us our area here. The cool thing about the section properties is you can get multiple faces at once. They have to be parallel. So one thing to note here is you have to have parallel faces to get the command to propagate. So if I hit recalculate, basically it gives me the area of both of the faces in total here. It's also cool because if you want to section something, so if I want to actually use my section tool and maybe I want to know the section of this face, I can grab that face and calculate it. Now keep in mind, like I said, because of parallel faces, if I wanted to grab this face and this face, it won't let me because now they're not parallel. So that's just something to note about it, like I said in the tip, right? The next one, sensors. This one's pretty cool. What it does is basically it monitors your model live as you edit it for selected properties. And what it's good for is it produces alerts when the values deviate from whatever the specified limits that are input by the user. So it's good if people are adjusting your models and you want things to remain in certain ranges, and it lets them know that they're basically violating the limits that have been set on that model. There's a variety of types of sensors, things like mass properties, so you can do sensors for mass, volume, surface area, specific dimensions. We can have a sensor for interference detection, of course on assemblies only, proximity on assemblies only, and then probably the one that they're mostly used for in most applications is simulation data. So in SOLIDWORKS simulation, those are things like monitoring stress, connector forces, and factor of safety regions. So if you put a specific stress limit on a specific area, you'll get a notification if your simulation violates that stress limit, right? So let's take a look at this example here. I've got a few sensors on this model. I've got one for mass and one for dimension. Very easy to add. Right-click on the sensor here, hit Add Sensor, and you could add sensors for those different things. So there's a drop-down here, and then there's a drop-down here for what you want to actually add. In this case, you can see how these actually work. I'll go ahead and delete that one. So the mass, if I change any of the dimensions on this part, so let's say if I adjust this dimension, you can see now that I've adjusted this dimension, I get a warning here, and it basically gives me the warning tab and says you've violated your mass, right? So my grams have gone over, I've set a mass of 1,000 grams, I've gone over to 1,152 grams. Same with this dimension. I set a warning on this dimension. Somebody comes in here and adjusts my dimension, makes it smaller than, I think it was 90, right? Now I've got a warning. This feature had an error. My dimension is, you can see if I hover over this, warning dimension is less than 90. So I went to 80, it's less than 90 millimeters. You can see now the mass is okay because I am underneath the limit that I set on that mass. So it's just a very simple way to add some warnings and indicators in here for people who are adjusting models. Performance evaluation. So this is a cool one that's probably frequently underutilized, but it's extremely valuable. And what it does is it lists all the features and their rebuild times in descending order. The key thing to note is what it's good for is it's good for troubleshooting slow rebuild times. So great for parts or drawings if you've got long load times or if there's issues with certain areas of that file loading, it'll give you feedback on what is actually causing specifically that issue. So you get feedback on your time percentage, so that's percentage of the total part rebuild time to regenerate, and the time in seconds that it's taking for each item to rebuild. So if there's something to note that's taking extremely long time to rebuild, you may have a problem with that geometry where SOLIDWORKS can't find something, or there's an issue, there's a conflict, and you can go in there and actually address that issue, and it kind of narrows down for troubleshooting to say, hey, this is the feature or the part of this drawing that's taken a really long time to rebuild, you know, what's happening in this feature, right? So let's take a look at an example here. To have this plastic part. If I look at that performance evaluation, I've got a pretty decent list of features and planes and sketches and all these types of things on here, right? And it basically tells me the amount of time that it takes for all of these features to rebuild and the percent of that time, right? So we know here right away that the surface loft is the most complex feature out of all these things that we have in our tree, and it's taking about 50% of the time to rebuild, or about 0.98 seconds, right? And the rest of these are pretty negligible, and most of them are even down close to 0. Now, the one thing to note here is you don't see all the decimal places out here, so even though it says 0, it may be 0.001, it may be 0.002, so you don't see that information. But we know here in this case that it's, about 50% of our rebuild time, so it is a significant amount, but it's still less than 1 second. So if you see something in here that's, quite long, or, in the minutes range, couple minutes, then there's probably a problem that you might need to address to get that repaired and speed up the rebuild time, right? So that's what that one's for, the keys for it. I highly suggest checking that out, especially if you're having a long rebuild time issue. Next one, check entity. So this one's kind of cool. It's good to check your model geometry if you have any undesirable geometry. Some of the examples that are included within this tool are things like invalid faces, edges. If you got real short edges, minimum radius of curvature, edge gaps, vertex edge gaps, all things like that, right? Basically, if I make a change that's something, real weird or out of the ordinary, like basically change super small radius here. So I'll make this like, see if that works. So there's a radius there. You can't really see it unless you zoom right in. If you do the check entity, you can turn on different checkbox, and some of these you can specify different limits on. I'll just turn them all on and see what I get. You hit check, and it basically gives you a bunch of feedback here telling you, hey, you've got a minimum radius feature here. You've got some real short edges, and it even gives you a nice little arrow in the graphics window pointing to where the actual error is. So it says, hey, there's short edges here. You can zoom in and actually look at what it's talking about. So it's like, okay, that's a really, really short edge. And it gives you some feedback, like the indicated edge is shorter than the maximum allowable tolerance. You may have a poorly aligned or nearly coincident sketch entity. Inspect this sketch for these conditions. Okay, so it gives you some feedback on things that you want to check. There's a vertex here that's really small. Minimum gap between vertices gives you the limits. Geometry analysis. This one's kind of similar to the check entity one. It gives you some different feedbacks, but some of the same as well. So there's some overlap here, right? So what it does, it's another method to check for other geometry errors. Gives you feedback about different geometry. The short edges, small surfaces, sliver surfaces, knife edges, vertexes. What it's good for is really identifying problem areas for other applications like FEA, simulation, or machining. So if we run the geometry analysis on this, once again, you can specify different limitations here, different tolerances for things like short edges, faces, sliver faces, angles. If you have, it's good to know if you have knife edges or knife vertices. We hit calculate. It runs through everything and kind of detects everything and processes what's going on here, and then it's going to give us a little feedback on what we got based on our limits that we set. Now I just left these limits as defaults here, but if you have specific limits that you're trying to work around, and then it points to it, right? So I have an edge here. I think the limit I set was 1 millimeter. There's an edge that's less than 0.09. So I can zoom in here and look at it. So I have a really, really small edge right here, right? Now some of this stuff may or may not be important. Some of it's just maybe good to know. It's telling me I have a couple knife vertices. So on this side here, a knife vertice exists right there, right? And you can cycle through all these. There's a couple discontinuous edges on this part that may or may not be important. And this also comes down to the method of manufacturing, right? Some of these things may be important for different types of manufacturing methods. Like if you're going to cast this part, it's probably not a big deal. If you're going to mold this part, it may be a big deal. If you're going to machine this part, you're probably going to have some issues with some of these vertexes and stuff like that. So it's just something to note and be aware of. The other cool thing here is you can actually save a report out. I'm not going to go into that, but it is an option. So import diagnostics. This one's a great tool. I've used this one quite a bit. Basically what it does is it repairs faulty surfaces. It knits repaired surfaces into closed bodies, or it can make closed bodies into solids. So why? Why is this important? It's great for imported surface data that has problems that prevent surfaces from being converted into valid solids. So this is good if you get like a dumb geometry from a vendor or another user. of a different CAD software maybe even that sent you something, and the geometry needs to be repaired. So you can do it manually, but why wouldn't I want SOLIDWORKS to do the work for me, you know? So what it's good for is repairing the geometry so you don't actually have to do it manually. And open up this step part of this, right? So as I open up this, it brings in the dumb geometry for me, creates the model. I don't want to do feature recognition. I'm just going to do a import diagnostics. And the way you get to this is if you right click here on your imported body, say import diagnostics, and it tells me right here, you have 3 faulty faces. And as you click on these, it cycles through the different faces and tells you where they are. So all of my errors are right down here somewhere in this corner, right? Now the best thing to do here is just right away just say attempt to heal them. Heal all faces for me. I don't want to do this, right? So it's healed 2 out of 3, right? So I'm going to do attempt to heal all again, see what happens. Okay, it left me 1 error. So now I'll have to come in here and actually do some surfacing techniques and other things to actually repair whatever this error is once I figure this out. So it just tells me there's a general geometry problem. But it got 2 out of 3, right? So normally, depending on how complex the error is or what the issue is, you can do the repair and it'll probably hit most of them up. If there's something real weird going on, you may have to do some manual repair, but definitely try to run this first because it'll save you a lot of time. And if it can repair everything, then you're good to go, right? So the next one is deviation analysis. This one, pretty straightforward. It calculates the angle between faces. So you can select a single edge or a series of edges. It's really good for molds, fillets, tangency, curvature control, surface optimization, stuff like that. Kind of the example here is this molded part where I have an arc and I basically do the deviation and it tells me what my deviations are throughout the arc. Right? I'll look at this one really quick. You can pretty much grab any edge or anything like that. So if I do a deviation analysis, say if I grab this arc right here and do a calculate, it gives me feedback on the deviation throughout that arc, right? May or may not be useful to you, but just know that it's there. You can change the colors. It gives you the degrees of average deviation, max and min deviation for that arc. There's another example where I have a tangency and it's giving me the deviation on that curve. Zebra stripes. These are cool. What it does is it basically shows small changes in a surface that's pretty hard to see with just your standard display, right? So it's really good for just identifying wrinkles or defects in a surface and verifying contact tangency or continuous curvature of surfaces. So same thing here. I'll show you this dustpan model. Turn on zebra stripes. This one's got some cool info because it basically shows the curvature on some of these different curves and how they're kind of interacting. You can also change a couple things within this if it's really necessary for you. You can change like the number of stripes, or you can change the thickness of the stripes, right? Kind of show it however you like to show it. But that's basically what that one does. It's kind of just a visual representation of some of the curvature on the surfaces or the small changes. Couple examples here as well. So this top left one here, we can see that the zebra stripes are showing the boundary not matching. And then the next one over, the zebra stripes show an abrupt change in direction. So if you got a lot of boundaries and a lot of surfacing going on, you can see where if you got good blends or not in some geometry, right? It's really for some kind of organic geometry. The two on the right, on the bottom corner here in the bottom right, the one shows the abrupt across boundary versus smooth across boundary. So if you got a real abrupt change in a surface, you can see that real easily versus if it's a nice smooth blend, you can see that as well. All right. So what does curvature do? It displays a part or assembly with the surfaces rendered in different colors according to the radius of curvature. So one thing to note here is curvature is the reciprocal of radius, so it's 1 divided by radius. So as the radius decreases, the curvature will increase. What do the colors mean? The colors change from black, which is essentially 0 curvature or a flat surface, through blue, through green, and red, which is 1. So the tip here is you can also right mouse button and select single faces to see a curvature display. So let's take a look at this dustpan again. We can right click and we can do a curvature display in here as a single face. So that's kind of cool, right? Or we can just turn on curvature and it'll show us the whole model. Now if we hover over any of these faces, it'll tell us what the actual curvature of that face is. So you can see this face here is a flat, so it's just black. The curvature reads out at 0. If we hover over this one, you can see the curvature is about 0.065, 0.067, depending on where we move it. Same thing here with this black one, it's 0, it's flat. If we check this one out, the curvature is about 0.018. And we can look at all these and see what the curvature is. It's just feedback on the curvature of the surfaces, all it is. You can see where you have actual curves or flat surfaces. Symmetry check. This one's kind of cool. I really do like this one. What it does is it checks for geometric symmetry in parts about a plane, a face, or a point. And what it's really good for is working on a portion of the model, and which can save design time and performance. So if you got a model that's like symmetrical in half or a quarter, you can pull that half or quarter model out of here with one click. So you use the tip here is to use the automatic symmetry split to create a half or quarter model on the fly. And I'll show you something cool with this one as well. So if we look at a model here, say I have a symmetric model that's symmetrical in both planes here, right? If we do the symmetry check, if I do the automatic symmetry split, so one thing to note here is you can define it by a single plane, parallel faces, or 2 points. But what's really cool is the automatic symmetry split. So it'll automatically split that symmetry, and you can see that it makes the cuts for me. So there's my half model, there's a quarter model, there's a quarter model. So if I want to do a body for split, I can select that body and just say split part, and it'll automatically create that quarter model for me. So this is great if you want to run some sim or something. You can save some RAM overhead and just use the quarter model, and it's already set up. And you can do this in simulation as well. The one thing to note here that's kind of cool is the symmetry check actually shows up in the tree now as a split. So there's a split command as well. So you can get the same result from the split command here, or you can get it through the symmetry check, which kind of does it automatically. And then if I actually edit this split command, what I get is the capability to do some other things like cut parts, utilize the trim tools, keep some of these bodies or cut them away, change the names, stuff like that, right? So there's a variety of different options that kind of come after I do the split. And you can see that quarter model there. So that's a pretty useful tool. It makes things a bit easier, just a quarter a model or half a model if you're doing something with symmetry, right? Thickness analysis. This one's kind of cool. It's used, as you can imagine, to determine different thicknesses of a part. What it's good for is identifying thick and thin regions of a part to assess potential failure areas. The hint is it's helpful when designing thin-walled plastic parts, which I really like about this tool. The tip here is to use the report feature to get a summary of the part thickness in one click. And I'll kind of show you this one in the dustpan again, because this one's kind of cool. If you do the thickness analysis right here, you can specify the thickness that you're targeting and the thin or thick regions, and then you can tell it to calculate. So in this case, if I'm going to mold this part and I'm concerned about thin regions not filling all the way, if you know anything about plastics, injection molding, you want to always fill from thick to thin. So that may determine where I put my gate location. So that's how you'd want to use this tool. And right here, it's telling me, it's giving me some color-coded areas, and I can hover over those areas, and it actually tells me the thickness in that area. So you can see right here, my thickness is less than 1 millimeter. Right here, my thickness is less than 1 millimeter. So that tells me right away that I definitely would not want to gate from anywhere in this region, right? Because I'd be filling from this very, very thin region up to this thicker region, which is a little bit over 2 millimeters. So that's one great thing about this tool that I really like, that it gives you this color-coded feedback and kind of lets you know where those thick regions are, thick and thin regions. Okay, mold tools. These are pretty specific to mold design. I'm not going to get into too much depth of these, but basically, in summary, what these do, there's 3 of them that are typically used. There's draft analysis, which basically analyzes your draft angles of faces based on the pull direction or the parting line. There's a parting line analysis, which analyzes your parting line based on specified pull direction. And there's an undercut analysis, and this just checks the part for undercuts that could form when molding. So if you have undercuts in your part, that's not going to work. It usually will hang up on the mold or even get completely stuck in there, right? So those are 3 tools that are very specific to mold design. They're in the tab. They're also under the mold design, so they're right here. If you turn on the mold tools, I believe they're with that one as well. So if we look at mold tools, you can see that they have the same tools here. So they're combined in the Evaluate tab, and they're also combined within mold tools because they're specific to mold tool. Some of the advanced tools, which I'm going to save for another time as well, on the Evaluate tab, the Express tools. One thing to note about the Express tools is they're typically a good starting point, but they have very limited capabilities compared to the full versions of things like simulation, flow simulation, DriveWorks, right? So these are what they call the Express tools. The Simulation Express is probably one of the common ones that are checked out or used within this feature, or the tab here, the Evaluate tab. It's a good tool if you just want to get some real ballpark information. There is a bunch of limitations on it, but just know that they're there. They can be accessed, right? There's also costing and sustainability, which are both there, which I'm not going to dive too deep into there today just based on time limitation. So the action item I have for you guys today, after all this information, we looked at about 16 different tools here in varying depths. So check out some of the tools on the Evaluate tab. Use them to your advantage. Use the tools to help check your designs, right? That's what they're there for. They have a bunch of functionality and a bunch of quick features that are pretty easy to use and figure out. And hopefully what they're going to do is actually save time for you and ultimately make designing in SOLIDWORKS faster and even easier, right? So with that, I thank you guys for attending on this Wednesday. I hope you enjoy the rest of your day. Once again, I'm Jared Spaniel. Feel free to email me with any further questions at jspaniel@desai-solutions.com.